Continuing on, now I have these two shapes here, and go ahead again, classify each polygon by the number of sides and tell me whether it's convex or concave. So in this first shape, we have 1, 2, 3, 4, 5 sides. Since it has 5 sides, it is a pentagon. And then again, if we were to extend out this side of my polygon, or even this side of my polygon, we would end up touching a point on the interior of the shape, meaning that it is concave. And then with this one here, if we go ahead and count the sides, we have 1, 2, 3, 4, 5, 6, 7 sides, meaning that this is a heptagon. And then if we were to go ahead and extend out each side of this polygon, none of the sides would end up touching a point in the interior, so that means it is convex. And now we're going to go ahead and we're going to look at the perimeter of shapes. So I have this triangle here, ABC, graphed on my coordinate grid. And then I want to go ahead and find the perimeter. So remember, perimeter means that you're finding the sum of all the side lengths of your triangle or your polygon. And so I'm going to go ahead, I need to know the length of AC, the length of line segment CB, and then the length of line segment BA. Now, the nice thing here is that looking at this triangle, if we're going from point A to C, we can just go ahead and take the absolute value of our y values, because if we notice from A to C, they have the same x coordinate for both points. So really we just need to know what is the distance between our y values. And so we're going to take the absolute value of -3 minus 3, which is the absolute value of -6, and that gives us 6. So from A to C, that's a 6-unit difference. And then I'm going to go ahead and I'm going to find the length of C to B. And again, it's really nice with these 2 points because our y values are the same. They're both -3. So we only have to worry about finding the difference using the absolute value between -2 and 3. So if we find the absolute value of -2 minus 3, we get the absolute value of -5, which is 5. And then finally, we're going to do the length of A to B. So here we're going to go ahead and apply the distance formula. And I know I didn't show it in these steps here until I reached the end, but of course the distance formula does have the square root of all of this. So we have -2 minus 3 squared plus the quantity of 3 minus -3 squared, and then -2 minus 3 is -5 squared plus 3 minus -3 is 6 squared. -5 squared is going to give us 25. 6 squared is going to give us 36. We take the sum of those two numbers, it gives us 61. And then again, when we're talking about the length and the distance formula, it's the square root of this value here. So we're going to take the square root of 61, which is approximately 7.8. And then again, I want to find the perimeter. So I'm going to take these 3 values and add them together. And that's going to give me 18.8 units approximately. Go ahead and we're going to find the perimeter of DFE. So from F to E, the value here is going to be 8, because again, same y values. And then E to D, we're going to go ahead and we're going to use the distance formula and take the difference of our x values and our y values, square them, and then take their sum. And that gives us 45. The square root of 45 is approximately 6.7. And then from D to F, again, we're going to take the distance formula and apply it here. And then that's going to give us 61. And take the square root of 61, and that gives us approximately 7.8. And if we take these 3 values and take their sum, we get 22.5. And then I'm sorry, in this problem, instead of AC, CB, and BA, it should have said FE, ED, DF.